you're writing this stuff to tape, but that doesn't match what was on the disk, and there's something wrong there. So then you'll know that your backup is not proceeding correctly. Okay, the one letter shorthand for this is D. Okay, for the diff. Okay, and this is and this is useful. You know, don't be alarmed though if you come across some errors when you do this kind of diff or compare, especially if you're backing up directories that are, you know, dynamic, like mail spools or log files or things like that, because they're certainly going to come back with errors, because it's different what you wrote to the tape, and then after you wrote it to the tape, it checks back to the disk, and what's on disk is different, and that's because, you know, some log file has changed, and so it says there's an error there, when the error isn't, you know, really an error. It's just because the log file's been updated since you did the tar. Let me show you an option for the tar command that makes incremental and differential backups really simple. So basically we do the exact same tar command that we did before, like tar cvpf, and then we give the directory or the device that we're going to back it up to, and I'll just call it tarball2 here. And then before we give the directories that we want to actually back up, what we do is we use the ---- newer option, and then we give a date there, okay, like 20th of May 02. Okay, and then we give the directories that we want to back up. So this is going to back up everything from /home and /etc that's been modified since the 20th of May 02. Okay, so that's a nice way to do incremental and differential backups. Now when I hit enter here, a bunch of stuff's going to scroll by on the screen. Maybe you could tell that the amount of stuff that scrolled by was less than when we did the full backup of home and etc. Maybe you couldn't tell that. It definitely was. If you scroll back here, you know, there's just not as much stuff in here as there was in the full backup of /home and /etc. Another good resource for backups on the net is called linuxbackup.net. I've bookmarked it here. Okay, so it's called linuxbackup.net, and there's good stuff in here. There's example backup commands, there's backup programs and scripts, so there's just ready-made scripts in place that'll do your full backups and differential backups and incremental backups, and you just set the parameters, how often you want them to do it, what you want the files to be named when they're done, and that kind of stuff, and they're just ready-made scripts ready for you to use and do your backups. Now let me show you how to use tar to restore a file from the backup media. So I've got this file linuxsyllabus.txt in my home directory here. I'm just going to remove it. And now you can see that it's gone. And if the user does this and they don't want to recreate the file, they might come to the system administrator and say, hey, can you restore this file from the backup media? And this is very easy for the system administrator to do. Now, one note before we do this is that when this file is in my home directory, right, the absolute path name to this file is /home/perry/linuxsyllabus.txt, okay? However, in the tar archive, all leading slashes are always removed. Okay, so this file name becomes home_perry_linuxsyllabus.txt. Okay, the leading slash is gone. So there are no absolute path names in a tar archive. There are only relative path names. So if I'm going to do this restore, I have to be up in the / directory for this to work. Okay, so let me go up to the / directory here, and we'll do this restore. Now the way that you do the restore is you do the tar command, and instead of C for create, we're going to do X for extract, and we're going to do V for verbose, P for same permissions, F for file, and then we give the device or the file that we're extracting from, so mount zip tarball1, okay, and then what we do is we give the directory or the file that we're going to restore, and in this case it's linuxsyllabus.txt. Okay, notice there's no leading slash on the home because the file is not stored in the tar archive with that leading slash, so it wouldn't find it if I put the leading slash on there. All right, so here's our thing, and I'm going to say enter, and now if I go down into the home Perry directory and do a listing, you'll see that my linuxsyllabus.txt file is now back, and I've restored it from the backup media. Now, if you don't know the name of the file that you want to restore, if you go to the system administrator and you say, I named it syllabus something or other, I don't remember, then the system administrator cannot extract it directly, and instead what you're going to have to do is look through a listing. And then after you look through the listing and get the exact name, then you can do the extract. So let me show you how to do a listing of a tar archive. So we're going to say tar, and instead of X we say T, or if you're doing the longhand format you would say --list. Okay, now here I say tvpf, and I'll say mount zip tarball1, and I'm going to pipe this through more because it's going to go rolling off the screen if I don't. All right, now I'll do that, I'll hit enter, and now you can start to see the stuff that's in the tar archive. If I hit spacebar, I'll page down through it, and you can see all the different things that are in the tar archive. Once I find the file that I want to restore, and I get the exact name, then I can stop looking at the listing, hit Control-C and actually go back to my tar command and say, okay, restore this file now because I know the file name. Another important maintenance task is to keep track of how much swap space and how much main memory or RAM you're using on a regular basis. So let me give you a little review of swap space and how it interacts with main memory, and then we'll talk about how to monitor the use of these two and also how to increase the amount of swap space on your computer. All right, so the swap space, that lives over on your hard disk, and there's some section of the hard disk, it's a partition, that is reserved for swap space. And swap space is basically just like a temporary holding place for something that used to be in main memory. Okay, so here's your memory cards over here, and what happens is some process is active, it comes into the system, it's active, and it uses up some of main memory. Then some other process comes in and it uses some of main memory, and some other process comes in and it uses some. And all these processes are active, okay? They're all getting little slices of the CPU over here, and they're all being used. Okay? Now, some new process comes in, and it needs some main memory to operate. Well, the operating system doesn't have any to give it because it's all filled up. So what the operating system does is it sort of determines which one of these is, the most idle. It hasn't been used in the longest amount of time. And it takes that stuff and it writes it out to the swap partition. Now that frees up some main memory so this process can come in and use some of that main memory. Now the stuff that was written out to the swap partition is going to be needed eventually. All right? So that's going to have to come back into main memory eventually, and at that point the operating system will take something else and write that out to the swap space. Okay? So there's this constant fluctuation between what's in main memory and what's in the swap partition. And that just keeps flip-flopping. The stuff that's in main memory is the more active stuff. That's the stuff that is getting slices of the CPU time and being operated on by the CPU. And the stuff that's in the swap partition is less active. It's more idle. Okay? But they definitely, things change from idle back to active and from active to idle, and things just go back and forth from the disk to main memory. Now the question is, how much main memory should you have? How much swap space should you have? And they're hard questions to answer in absolute terms. It depends on what you're doing with your system. But there's a relationship between these two that you should keep in check. So depending on how much main memory you should have that much swap space and then some. How much more just depends on what you're doing in your system. Certainly you should have like 1.2 times as much swap space as main memory. But it's more like 1.5 or 2 times as much. And one thing to note is that depending on your kernel number, if your kernel number is 2.4 point something, those kernels use more main memory or use more memory in general, and so your swap space should be higher on 2.4 kernels than on 2.2 kernels in those previous. Okay, so keep that in mind when you're determining how much swap space to put on your system. Like I said, 1.5 to 2 times as much as main memory. Now let's talk about how to monitor your system's use of RAM and swap space. Okay, so the basic command to do this is the free command. We can use some options with free, but we won't use those right now. We'll just do free by itself. Now there's a few lines here. The first line is the main memory. And this is the total amount of main memory you have, this is how much main memory you're using, and this is how much main memory is free. And you can see by this little chart here that I'm using about 85–90% of my main memory. Now, that seems like an awful lot, but actually this estimate here is a very conservative estimate of how much is free. It's telling you, definitely this much is free, but there's probably a lot more free. And this line down here is a correction of that. Because there are buffers in main memory for things like input-output to your disk and caches and things like that. And those elements, the buffers and the caches, are just assumed to be completely used in this number up here. So all those things are assumed to be completely used. But like I said, this line is sort of a more correct estimate of how much space is free. All right? So somewhere in between these two, closer to this number, is the amount of free space that you actually have in your memory. And then there's this number down here for the swap partition. So this tells you how much swap partition there is, how much is used, and how much is free. And you can see the swap partition on my system is like twice the memory size. Okay, and I'm using a 2.4 kernel, and like I said, for 2.4 kernels, you want a swap space that's like twice your main memory size. All right, so this is the basic output of free. This number over here has to do with the kernel numbers, how much shared memory the kernel's using. That's not too much of an issue for us. The main stuff here is this free column and this used column and this total column. Now, if we look at the man page for free, you'll see a couple different options that we can use. There's the -b, -k, and -m options.